One of the coolest deep learning results from last year was the Google Translate update. They've been a leader in machine learning for a while, but implementing a deep neural network for translation brought the service nearly to the level of human translators. With translation, the correct word to use depends on the context, on all the other words in the sentence, and even in the paragraph. Much of the information contained in language is in the sequence of the words. So far, we've been working with what are called feed-forward networks. The input is fed into the network and it propagates forward through the hidden layers to the output layer. In feed-forward networks, there is no sense of order in the inputs. Here's a simple idea then. Let's build order into our network. First, we'll split up the data into parts. With text, this can be words or individual characters, like I've done here with the word steep. Going forward, I'm going to borrow an example from Andrzej Karpathy because it's great. Our goal here is to predict the next character in the word steep. To keep it simple, assume our entire alphabet consists of S, T, E, and P. Let's start with the normal feed-forward network. We'll pass in the character S, and our desired output is T. When we pass in a T, we should get out E. Now we pass in that E. In this sentence, E is followed by another E or a P. The network, as shown here, doesn't have enough information to determine which character to predict. To solve this problem, we'll need to include information about the sequence of characters. We can do this by routing the hidden layer output from the previous step back into the hidden layer. That box there means values from the previous sequence or time step. Now, when the network sees an E, it knows it saw an S and a T before, so the next character should be another E. This architecture is known as a recurrent neural network, or RNN. Now, the total input to the hidden layer is just the sum of the linear combinations from the input layer and the previous hidden layer, ht-1. We could view a recurrent network as one big graph by unrolling it. Now we have a feed-forward network for each character, but connected through the hidden layers. Each hidden node receives inputs from an input node and the hidden node from the previous step. To make it a bit more understandable, let's plug in some numbers here. This diagram is borrowed from Andrzej Karpathy with a few alterations. Here, we're one-hot encoding the input characters, so 1000 is an S, 0100 is a T, and so on. There are 3 units in the hidden layer and the output layer showing the logits. You'd pass the logits into a softmax function to get predictions and train with a cross-entropy loss. This is the basic architecture for a character-wise RNN, but there are some improvements we'll need to make, which I'll talk about next.